Go. And Mark, get set, let's go. Today we're going to talk about log equations when we are able to use a calculator. All right, so first scenario we'll talk about is how do you solve something like 16 to the x power equals 321. This is kind of like just the logs 101 here. Hey, we're trying to figure out what this something to this power is, and it's not some like nice, neat little friendly power. This isn't some happy little problem anymore, is it? It's not a happy math book problem. 16 to the unknown power equals 321. What do you think? You could probably guess. We could use our calculator and guess and check. 16 to the 1 power, 16 to the 1.1 power, 16 to the 1.2 power, 16 to the, that would be dumb, 16 to the 2 power, 16 to the 2.2 power, right? We could guess and check and all that stuff, but that's kind of a bad strategy. So what we're going to do is we're going to use calculator and logs. Yep, calculator and logs. Good. So let's remind ourselves, how do you go from exponent form to log form? So if we have b to the x equals a, right? And we write that as a log, that's going to be what? The log of a base b equals x, right? Remember that? That's kind of like where we started out this whole unit, learning that stuff. So could we rewrite this expression as a log? There's a couple ways to look at this. We'll start out with, hey, let's write that exponent form as a log form. So if we rewrote this as a log, it would be the log of 321 base 16 is equal to x. Okay. Now, since we're using a calculator, I'm going to show you how to do that on the calculator. So I'm going to pause it here for a second. I'm going to show you the fancy calculator. All right, so here's our calculators. We have the TI Inspire. And if you go to a regular calculator page on the Expire, that was funny. I called it the Expire. A little slip there, a little Freudian slip there. Maybe I want these to expire. Maybe I just want my TI-85 back. Yeah, the 90s model. Anyhow, this is superior to the TI-85 because you have the log button, and the log, you can't really see this that well, but the log button is right to the left of the 1. So if you click on, you have to click on the Control 10 to the X button, and that gets you this log right here. That's one way to get the log. And the fancy calculators, the new ones like these Expires, you can type in the base. So if you don't type in a base, it's going to be 10, the common log, but you can type in the base. Just what were we trying to do anyways? It was this problem right here. So the log of 321 base 16. So now I can just go right in here, type in the base 16, pop over to the stuff 321, and evaluate. 2.0816. Okay. So these calculators have the ability to type in the base. However, not all the calculators do. So how are we going to handle that? How are we going to evaluate that? Well, let's think about this just in a little different way. How else could I get this exponent down from exponent land? Like, could I pull this down from here right now and rewrite it out in front? Could I do that right now? I can't do it right now because it's not a log of that stuff, right? But if it was a log, then I could. So what I'm going to do, another way to do this, essentially, so you could just rewrite it in exponent form if you have the calculator, beep boop bop, beep boop bop, and then you get your x, which is equal to, what was it, 2.08? Right? If you don't have that, you could log both sides of this equation. Let's say we have log of 16 to the x equals log of 321. Okay? And so once you take the log of both sides, now you have the ability to use the power property and pull that x down in front and rewrite it as x times the log of 16. So now we have x times the log of 16. Oh my goodness. Turn that into a 6 like Bart Simpson would. Equals log of 321. Now keep in mind that the log of 16 is a number and the log of 321 is a number. In fact, there is no base right now, right? Because I took the log of both sides, I took the common log of both sides. So now I made this has no base. Really, it has a base of 10, right? So now we're using the common logs. And the common log is what is in the more basic calculators, the little ones that you have. So now how could I get x by itself? Could divide both sides by what? The log of 16. And of course, I'm just going to write the base in just to reiterate, but it's the common log, so we're just using base 10, which is what we have in most of those smaller calculators. Now the log of 16s cancel out, and I'm left with x is equal to the log of 321 divided by the log of 16. You got to be careful. It's not the log of 321 over 16. It's not this. I see people make this mistake. It's not that. Okay? It's the log of 321 divided by the log of 16. So now let's go over to the calculator again and see what happens when we put that in. Any predictions? I better type it in. I don't know. Or not type it in. You think it's going to be the same? Good prediction. Ta-da! So, what's happening here is we sort of discovered kind of a formula. Okay, it's called the change of base formula. And I'm going to pop over to the next page because I have this change of base formula written down here. The change of base formula says that, and I'll probably end up using different variables than the book does or something. But let's just say we have some generic log, like the log of whatever we used, which is a base b equals x, right? That is the same as the log of a divided by the log of b. And these are common logs, so the base is 10. Normally I don't write it in, but I just want to make sure that you don't miss that part. And I guess I probably don't even really need this x here. So the log of a base b is the same as the log of a over the log of b, but they're common logs. So that allows you to evaluate a log with a different base than 10 using a calculator that's not a fancy one, right? Like look at this problem right below here. If you didn't have the fancy calculator, how would you evaluate that? Well, you'd have to do the change of base formula. So this will just take some repetition. This is going to be the same as the log of 97 over the log of 6. Right? Okay, they're the same exact thing. What about this one down here below? Log of 92 base 10. Do we need the change of base formula for this one? This one we don't need change of base formula because it already is a common log. All right, so we don't need to use change of base for that one. So you don't have to do it for everything. It wouldn't hurt. What if we use a change of base formula? It just would be kind of silly, right? The log of 92, what is the base? Over the log of 10. The log of 10. That's funny because you know what the base is? 10. So what's the log of 10 base 10? It's just 1, so you're just not doing anything. So it's like, it's just kind of silly to use the change of base there. It's that it wouldn't be wrong, it wouldn't hurt anything, it just doesn't matter. All right, what about this one here? Natural log of 45. What's the base on that? E. Okay, and you probably have a natural log button on your calculator. Why don't you find it? Oh, there it is, ln. See it? All right, so there will be a natural log button on there, and the natural log button will have a base of E. So you just type this in your calculator, natural log 45, and that will tell you whatever you need to know. On Calc, ln 45, was it? 3.806, ka-chow. What was the log of 92? 10 to what power is 92? This is going to be less than 1, I believe, isn't it? Wait, no, not less than 1. Less than 2. 1.96. Ka-chow. Good. What do you think? Change your base formula, get it? What was the log of 97 base 6? Did you do that one? 6 to what power is 97? Well, 6 squared is 36. It's going to be between 2 and 3. 2 point who? 55? Ka-chow? Right. What about this one, log of 467 base 4? If you have a fancy calculator, just type in the thing. If you don't, you got to use a change of base. Log of 467 divided by the log of 4, which ends up being, let's see, 4 to what power is 467? I'm going to say 4 to the 4th is 256. I'm going to say it's 4 point something. 4.43. Okay. All right, so there's that a little bit. That's a change of base. I'm going to pop back to the previous page. We have a variable that's an exponent. So there's two ways to deal with this. You can rewrite it in log form, or you can take the log of both sides and pull the exponent down. I think just rewriting it from log to exponent, exponent to log is the way to go. So let's rewrite this as a log. And let's go with the log of, what's the stuff, Boley? What's the stuff here? The log of 1,000. Good. And the base is 7. And it equals, this time there's an expression, so it equals the whole 2x minus 3. All right. And this is a calculator, so you have the ability to evaluate log of 1,000 base 7, right? And then all I want to do at this point is get the x by itself. So what am I going to do to get rid of the 3 and the 2? I'm going to add the 3 to both sides. So I got to add 3 to that stuff. And then I got to take that and I got to divide it by 2, right? And then I got to divide by 2. So when we're all said and done, our x is going to be equal to the log of 1,000 base 7 plus 3 all divided by 2. And you might need to, if you don't have a fancy calculator, to evaluate the log of 1,000 base 7, you might need to do the change of base, which is the log of 1,000 over the log of 7. Right, so you type in your calculator, log of 1,000 base 7, and then you'd add 3 to that answer, and then you divide 2 to that answer, and you'd end up with whatever you'd end up with. 3.27. Anybody second that? Only one person. Oh, yeah. Good. Any question? Don't be afraid to ask questions just because I got the air traffic controller headset on. I was talking to an air traffic controller last night on the train ride home from Northfield. Retired guy. Birdall? Was it Birdall? No. I don't know. I forgot their name. You're looking at me weird. Leif? Is that right? Is there a Leif or something? Anyway, this is going on the YouTube, so if you're listening out there. Let's wrap this up. Hey, Robbie? All right. So, natural log has a base of what, Mr. Dale? Robert Dale? E. Good. So, in this case, the natural log of x equals 2.1. We threw some curveballs in there. This one is going to be e to the 2.1 is equal to x if you write it from log form to exponent form, right? So don't forget all the stuff you know just because we learned something new. Can you do e to the 2.1? Yep, there's a button on your calculator. It's actually the inverse natural log button. So if you find your natural log button, e to the x button will be probably behind it or in front of it. And so you would type in e to the 2.1 on your calculator, and you'd be off and running. Right? Let's see where it is on this calculator. It is right there. It's in front of the natural log. E to the 2.1, 8.17. Okay. E to the 2x minus 4 equals 86. How do I get rid of that, or how do I get that variable down from exponent there? What can I do? How can I get rid of exponent form? How can I solve for a variable that's an exponent? Maybe I should call on someone. Suddenly they all just got a little nervous. Tuamas is avoiding eye contact. Riley? Yeah. What? How would I get this exponent down from here? I gotta solve for that stuff. What am I gonna do? Write it as a natural log? Huh. That's a good idea because it has a base of e. So instead of writing it as a log, you'd write it as a natural log. If you wrote it as a log, it would be fine too. If you wrote, okay, let's write this in log form. The log of 86, what's the base? E. Okay, well the log of base e is the same as saying ln with no base. And that's going to equal 2x minus 4, the exponent, right? I'll write down what I said earlier. So the log of 86 base e, that's also like saying ln, which is a natural log of 86. And then now I have to undo the minus 4, and I have to add 4, and then I have to undo the times 2 by dividing by 2. So in the end, I'm going to have x is equal to the natural log of 86 plus 4, all divided by 2. Not too bad, eh? All right, couple twists and then we'll be done. here we have some stuff that is being multiplied and subtracted to the stuff that's to the power where the exponent is. So this question is kind of like the one we just did, sort of, except for we got some stuff that's bugging me, like this stuff I want to get rid of and that stuff I want to get rid of first before I write it in log form. Okay, so I want to just move that to the other side. So first I'm going to add the 9, and then I'm going to divide by the 4, right? So when I add the 9, I'm going to get 56. When I divide it by 4, I'm going to get 14, I believe. So when you get that stuff all by itself, it's going to be 3 to the x plus 2 power is equal to 14. How did I get 14? Well, I added 9 to both sides to get rid of that, and that gave me 56, and then I divided 56 by 4 on both sides, and I got 14. And then now I'm going to take it and I'm going to write it in log form. So this is going to be the log of 14 base 3 equals x plus 2. And to get x by itself, all I have to do is subtract 2 to both sides. So I have the log of 14 base 3 minus 2. And if you don't have a fancy calculator, then you got to do the log of 14 divided by the log of 3 and use the change of base formula. It's really not that hard. Just have to know what to do. Any questions or comments, concerns, compliments, money, cash, tips, smiles? I like smiles. Real ones. All right, last one. How do I get rid of to the 1.4 power? What the heck is, what in the heck? How do you do, we've been talked about this a whole bunch yesterday. How do you, like, do the inverse of a power? Like x to the second power. What's the inverse of x squared? How do I get rid of that? You say square root, but I've been trying to get you to just go like 1/2, right? What's the inverse of to the 1/3 power? 3 power, okay? What's the inverse of to the 2/3 power? The reciprocal, right? What's the inverse of negative 1/4 power? Negative 4 power, right? Okay, so what's the inverse of to the 1.4 power? What are you scared of? You seem to be on a roll there, and then you got stumped. Just say it. What do you think it is? Go ahead. Kaya, what do you think it is? Okay, what if I write 1.4 as a fraction? Is that what you're thinking? Maybe if I write 1.4 as a fraction, that would be 14/10, which is 7/5, right? 5/7. But you don't have to do that. You can just go like this. 1 over 1.4, because it's a calculator, you know? It doesn't discriminate between 7/5 and 1 over 1.4 like math teachers would. 1 over 1.4, you can't write it like that. Calculator doesn't care. So take both sides to the 1 over 1.4 power, and you'll get x by itself. Get rid of all this jazz here. It was good practice. So this is going to be x equals 50 to the power of 1 over 1.4. What is it? Oh, you can't do it on there? What did you get? 16.3, that sounds right. 16 point who? 3.5. Yeah, because 16 to the 1 over, wait a minute. That's not right. 35.7? Are you sure that's right? All right. Anyway, so take something to the reciprocal power to get rid of the power. That's all I got. 25-minute video. There's a lot of stuff you can fast forward on here. Sorry about that. But we're coming to you live on a beautiful May 14th, 2019. All right, we have to fix this last one. Apparently, that is, whoa, that is wrong. It actually was the first answer, which was 16 point whatever 35, which, or is it just yeah, 16.351. We're gonna round to the nearest hundredth on this worksheet. So 16.35 was the correct answer. You got to be careful when you're typing that stuff in. Sometimes you got to use parentheses around stuff and this and that. So nice job, Kaya. You were right the first time. High five.